Okay, this is going to be a little bit interesting. I wanted to go over a few concepts, which were not so clear or seem to be confusion still in the first exam. So one of those concepts is a floating node and then the voltage difference. So you can see this. Okay, so here's my circuit. I'm going to have a battery. Okay, so I'm going to hook up the battery. It's going to be in the positive side, and then the negative will be in the negative. So the positive side of the battery. So on this, you can see that I'm going to hook up the positive side over here. There we go. Okay, so positive side of the battery, just connected here, goes into this first resistor. And on that, you can see that it is, maybe not, there we go. It's connected all in that line. And then I just did a jumper wire to the next line. And then that's another jumper wire to the next resistor. And then that resistor goes to the ground portion. And then this resistor goes to another resistor and then to ground. So to draw this, this is going to look like this. I have my battery. And then I have that blue wire that goes to the resistor on the top, which is this one, R1. And then I have additional wires here. And there was 3 of them that then go to this one, which goes to ground. And this one, which goes over, and then another one that goes to ground. So this is my circuit here that is exactly the same. So my point that I want to make is all of these little jumper wires, if I was to measure each one, what should I expect there? 0 voltage difference. So it should be the same at every single little wire. So just wanted to go through this exercise just because this seemed to be a concept still a little bit lacking. So we're going to physically do this, sorry. All right, so this node here that's right above the battery, this is 9 volts. I should measure about 9 volts there, right? So on this circuit, that is going to be where I literally just took it in. And so there's a wire in between there, that blue wire. And I do measure, around 9 volts. So that should be what I expect. So notice that there's still a wire in between there, just like there's a wire there. So if I was to measure here, it would still be 9 volts, correct? Okay. So that's the concept that I want you to think about, is the physical part, which is there's actually physical wires, but the location may be different, but the voltage is still the same. Okay. All right. So then if I measure now over here, I'm going to have a voltage drop, right, across that resistor. So now I'm measuring 298 millivolts. So on the circuit diagram, that means that I'm at this location right after the resistor, and that's 298 millivolts. So I should also measure 298 millivolts here, right? And here, right before this resistor, right before that resistor. So if I put this on, I lost my negative connection. So now at a different place in that wire, I should still be measuring what here? 298. So there's 298 millivolts. And I shouldn't be measuring it along that same wire. This is again a different location, but it's still 298 millivolts. And then across here, I should be measuring on this side of the resistor. I still measure 298 millivolts. On this part of the resistor, I should still be measuring 298. Okay, So I want that concept to kind of be in there, that even along each wire, all along that wire is the same voltage. So that seemed to be a little bit of a confusion still. I thought maybe this demo would help to be like, oh, that makes more sense. You know, physical location may be different, but the voltage will be the same along each of those, because a wire is the same voltage value wherever that wire is. Okay. All right. The other concept is that if I have now a floating wire, so now if I take that off, my circuit is going to look like this, and I have a voltage source that goes to ground, and now a resistor that is just floating there. What will I measure here? Should measure 9 volts. Why? Correct. Yep. So it should still be just 9 volts. So as I measure here, I can grab that. You see that, yes, there's no volt or no current going through there, which means no voltage across that resistor. Yes. You have to have a closed loop in order for current to go through it. So, yep. So I have to have some way of connecting this, you know, to ground, but because it's open and just floating there, there's still a difference in voltage between that location and ground, right? So between this location and ground, where it's still open in air, there's still a voltage difference there. And so that's why we're measuring, you know, 9.17 volts across there. But that is the same between those. Does that make sense? Okay. So this concept didn't seem to be solidified. So think about this, make sure you do understand that. So now, you know, if you're looking at, you know, when we draw, like, you can draw something like this, where it's open, but there's no current going through these dangling wires. But this means that I would put the red probe across this to ground. And I'm going to measure the resist or the voltage across this resistance at this location here. That is the same as I've hooked now these dangling wires, and I hook it across that last resistor there, which is there. And I lost something. Oh, I'm not hooked up. I'm like, wait a minute, it's 0 volts. Okay, hooking back that resistor in there. And so across this is my dangling wire off of it, and then that's my black one on the end. So it's just like this with the red probe here and the black probe here. And I get 295.4 millivolts. 295 millivolts. So the other concept is that when I want to take a difference between two locations, this location and this location, what will I measure here? If this, what is this value here? 298 millivolts. It will be what? Yep, it will be the voltage across this resistor. And from the values I measured, what will that be? 3 millivolts. And how did you get that? Correct, the differences. So it's whatever is on the one side, subtract off the other side. So in this case, it's 298 minus 295. So the plus side, I put that probe, and now I'm comparing it instead of from ground, I'm comparing it across the resistor. And yes, I do measure 3 millivolts there. So across this resistor, I've taken the voltage that I have at the positive side, and I subtract off the voltage I have on the negative side across that resistor. That is the voltage difference. And so whenever you see a voltage difference, if you don't see a difference and you see just a node, that's meaning that I'm going to be at, for example, we had it here, which was here, and that's always going to be compared to ground. So in anywhere in a circuit, a node is compared to ground, unless you see the plus side and the negative side, which in this case, we had the plus on this side of the resistor and the minus on the other. So then it's the differences of whatever voltages are there. Does that make sense? Okay, so those three concepts, make sure that you do understand